Good morning, directors. My name is Joshua Lau, and together with my team comprising of Kelly William, Joshua Quack, Caleb So, Ho Jun Rong, and TB06 G4 we'd like to present our project on Singtel and its churn ratio. Now for a brief introduction of Singtel. Singtel is a local telecommunication corporation that provides mobile, internet, TV, and fixed-line telephone services in Singapore. Currently, Singtel is facing a problem of increasing number of customers leaving their service. The task of this project will be to finding common attributes and factors between the customers that left, and also to forecast which customers will leave the service soon. We'll also make recommendations to take corrective measures and to make changes to improve the services so that Singtel has a better chance of maintaining their customer base. We'll be using RapidMiner to aid us in this project. Based on the picture here, we can see that we use the retrieve operator to help clean the data that we were given. However, as we were cleaning the data, we found that we were missing a total of 41 missing data sets, with 30 data sets coming from the attribute of tenure and 11 data sets coming from the attribute of total charges. Here we can see the 4 services that Singtel provides to their customers. By right, each data set should only have a yes or a no inside. However, we can see that there are some data sets that read no internet service, which are highlighted in red. This will pose a problem to us as we can see that the data sets are actually not consistent. Here we see the total charges that were given to each customer. The total charge that's highlighted in red is actually wrong, as 28 times 104.8 will give a total charge of 2,934.4. However, the total charge reads 3,046.05. This poses a problem as we can see that the calculations are not 100% accurate.
Hi, my name is Joshua and I'll be presenting the project task Data Preparations 3.1. Now, as you can see, as earlier mentioned, there were various things wrong with the data, such as missing numbers and wrong values. So here are the various operators we put into action in order to fix the problem. The first one will be replace the missing values. The replace the missing values helps us replace the missing values within the tenure and the total charges with the average number. As you can see here, for the tenure and the total charges, after running the program, there is no more missing numbers. Next up, we solved the problem of the various attributes that had the no internet services where it's supposed to be a yes or a no. Basically, we used the parameter replace, and we selected the attributes device protection, internet service, mobile service, online security, TV services, and tech support. And we asked the program to detect no internet service and replace it with a no. Because people with no internet services will obviously not subscribe to the various services. Next up, we solved the problem of not having the correct numbers within the total charges. The first thing that we did was remove the total charges attribute. We did this by using the remove attribute range operator, and we selected the range number, which was 13, which was obviously the total charges attribute. We later replaced the attribute using the operator generate attributes. And basically, we inputted a formula tenure times monthly charges, which is the formula to find total charges. We named this attribute total charges bracket new. As you can see, as a result of the operator, the total charges of row 9 is 2,934.4, which is the correct answer. This is the result of our entire operators. Next one, we'll be moving to data preparation 3.2. This question required us to select various attributes to use as predictors. So basically, we used the operator select attribute, and then we selected attribute filter type to be subset in order to select multiple attributes to use as predictors. Here are the various attributes we selected in the select. Let's start with the ones that we selected. So first we chose churn, which is required to see if a customer churns or not. Contract, basically we need this in order to see if a customer, if they're contracted with a company, whether they will stay in the company or not. Next up, we have device protection, internet service, mobile service, online security, TV service, and tech support. Basically, this can be used as predictors as if the services are not up to standard or up to quality, basically customers will not be satisfied and therefore will churn. Senior citizens are also a good predictor, as usually old people are not as inclined to technology as the younger people, and thus will be more inclined to churn compared to the younger ones. And now we refer to the attributes which we did not select. So first, customer ID and gender. If you look at this table, customer ID and gender have a very low correlation rate towards the churn. This is due to the fact that customer ID is randomly given to every single customer. Therefore, it is not that relevant when it comes to predicting whether customers will churn or not. Same goes for gender. Gender does not really predict whether customers will churn because it's a random thing given. And next we have monthly charges, tenure, and total charges, which are not included in the attributes.
Hi, my name is Kelly, and I'll be running through this part of data preparation, the first part of modeling. So we use the set row operator to set the attribute as churn for the label. On this slide, you'll see that we use the split data operator to split the data to 70% and 30%. And we use the shuffle sampling to give more accuracy to the model, even though it shuffles the data into random subsets. This is the results that we got from the previous slide. Moving on, the decision tree operator is connected to the first partition of the split data operator. This will allow for 70% of the dataset to be used as training data for the decision tree. The model from the decision tree operator is then connected to the result output, where the decision tree is produced. So we used the gain ratio criterion, and this reason is explained in our report. Moving on, these are the settings that we use for our decision tree. So the maximal depth, we have set it to 20 to restrict the size of the decision tree to prevent overfitting. The confidence, we have set it to 0.25, as toggling with the value would cause no change to the decision tree. The minimal gain, we have set it to 0.0125, which is a relatively small value, considering the number of attributes, which is 10, we have in our analysis, so that we would have fewer splits and thus a smaller tree. For the minimal leaf size, we have set it to 8, because a node will be split into 2 or more nodes if the subsequent nodes contain at least 8 examples, which is a higher value that will cause lesser splits and vice versa. For the minimal size of the split, we have set it to 5. So that means a node will be split up into 2 or more nodes if the larger node contains at least 5 examples. For the number of pre-pruning alternatives, we left it as a default value of 3, as the number of alternative nodes try for splitting when the split is prevented by pre-pruning at a certain node is fine for our model. Hence, we produced this decision tree following the above parameters and settings. Moving on, we then added the apply model operator into the process. The second partition of the split data operator is connected to the apply model. This allows for the remaining 30% of the data to act as a testing data to be tested on the model. The split data partition is hence connected to the unlabeled data port, and the decision model port connected to the apply model port. To test the accuracy of the training model, the performance operator is used after the apply model operator. How this works is that it measures how accurate has the model's training data successfully predicted churn rate in the testing data. During the apply model stage, the testing data for churn is unlabeled. When this apply model labeled output is passed through the performance operator, the performance operator compares these predicted churn rate values with the original churn rate values in the given dataset. This hence measures how accurate has the model is in predicting the churn rate for the testing data. We see here that a moderately good accuracy of 75.53% is obtained for the testing model, and the confusion matrix will be evaluated in the evaluation part of the report.
Hello, my name is Caleb, and I'll be running through with you the evaluations for our model. First of all, the model is 75.53% accurate. That is, for all 2,113 examples of the testing data used from splitting the data, the model only predicted churn correctly for 1,596 examples. Okay, looking at the second row of the matrix, the model predicted the value of churn rate no 1,440 times. The model was correct to predict no for 1,240 times. This hence gives rise to an overall class precision of 86.11% when the model predicts no. Looking at the third row of the matrix, the model predicted the value of churn rate yes 673 times. The model was only correct to predict yes for 356 times. Okay, this hence gives rise again to an overall class precision of 52.9% when the model predicts a yes. And now we look at the second column, and of the 1,557 testing examples which were actually no, in the labeled data, 1,240 of the examples were predicted no by the model, while 317 of the examples were predicted yes by the model. Now this hence gives rise to an overall class recall of 79.64%, where the model is able to correctly predict 79.64%. looking at the third column of the matrix, of all the 556 testing examples which were actually yes, in the labeled data, 356 of the examples were predicted yes by the model correctly, while 200 of the examples were predicted no wrongly. This hence gives the rise of an overall class recall of 64.03%. Now, look at evaluation 5.2. From this decision tree, we can come up with a few different evaluations. So first of all, customers with a contract with the company has a very low chance of leaving the company. That's one. Secondly, customers who do not subscribe to internet services of the company are not likely to leave the company. That's two. Thirdly, customers who contacted tech support before having a higher chance of staying on, while customers who did not contact tech support will leave Singtel. Fourthly, for those who are senior citizens, they will tend to stay on in Singtel. And lastly, those who contacted tech support tend to stay on in Singtel.
Hi, my name is Wei Xue, and I'll be leading you through the recommendations part along with Jirong. So, moving on with our first recommendation, this is to target the attribute contract. So for the contract between the customers and Singtel, we will encourage for the company to provide trial periods of their services to entice potential customers to purchase a contract from Singtel. The trial period can showcase their features as incentives for the benefit of their customers. An example would be to collaborate with Samsung in their selling of their curved TVs to provide a free trial of their services, like other telecommunication service. Moving on to our second recommendation, which is to target the attribute internet service, Singtel can look to improve the infrastructure so as to retain more customers from churning. This can capture a new market of customers who were previously not satisfied and increase customer loyalty. This is with reference for the evaluation as shown in the part above, as mentioned before. An example would be MyRepublic no contract internet plan, which the features are being shown in the slide below, and this could serve to benefit the first recommendations as mentioned above, as they will provide alternative as an incentive for no contract planners, no contract for customers. More customers would be less likely to churn with a more accessible internet service. The third recommendation would be to raise awareness of tech support. Online security is formidable with tech support. As such, Singtel can raise awareness of the usefulness of their tech support in their online security for their services. This would enable the customers to know that tech support is a reliable service for customers to rely on and for customers who might potentially churn on their services. An example is Bobcast, which has an ISO 9001-2015 certified support quality. They have a support engineer who is able to excel in all areas of technical support, which Singtel can model after to provide the same type of quality service for their customers. Without further ado, I'll pass my time off to Jirong to be telling you more about recommendation 4 and 5.
Hi, I'm Jirong and I'll be taking you through recommendations 4 and 5. For recommendation 4, we suggest putting more attention on high-risk customers. Singtel can provide incentives and offers to customers who are most likely to churn based on the predictions of the different attributes. We can predict and identify the potential customers that may churn and aggressively promote the company's services to these customers. An example would be to create customized emails to personally communicate with these customers. This is evident from Amazon, where the company customizes the customer's name in every order or transaction, which the company can follow after. For recommendation number 5, we suggest having more support for senior citizens. Senior citizens would need more tech support as they are less familiar with operating new technologies. If there is tech support for senior citizens, they will be less likely to churn. Therefore, we recommend opening a dedicated channel, hotline, and help center for senior citizens. Additionally, senior citizens will play an important factor in their children's choice of telecom company, where their children will use the same telco when they are young, retaining not only current customers, but also future customers. Thank you.